Assalamualaikum warahmatullahi taala wabarakatuh. How are you?
Waalaikumsalam, sir.
Yeah. Okay, good. Okay, today we're going to discuss the quiz. So I want you to take out your, get your answers for the quiz ready, because that is the only way I can discuss. I will give a full answer of the quiz, and then you can have some idea on, how you perform. Because when we do the grading online, I cannot really write down the comments, for your answers. So you have to do it on your own, and you can estimate now, you can estimate or have an idea how you perform. So let's go through the quiz. And today, okay, after I finish discussing the quiz, we will do the second derivative test to, for maximum and minimum for that chapter. I hope I can do that today. So first, let us discuss the quiz. Now we go to first question. Now the question number 1, that is about a linear function. Now when you have a linear function, what we want to do here is to find the linear function. And the problem here is the break-even. Okay, the break-even problem. So we know what is break-even. And then what you need to do here, you need to find the cost function and the revenue function. So for question number 1, you have the break-even question. Okay, here break-even. That means what you need is the profit. Okay, break-even means profit, which is revenue minus cost, that is equal to 0. So we have to know, all right, what the problem is about. And then we will approach it from there. So here, you need to find revenue. So let's start the revenue, because I think revenue is simple enough. Revenue is equal to P times X. And given, okay, given the price is equal to how much? 96.5. I think part A, we want to find the cost function, right? Did I say cost function? Because I don't have the question. Part A. Do we want to find the cost function, or but that's okay, I will, to find that revenue will be on part B. So part A, okay, part A, I will do it according to the parts. So part A, you need to find the cost. Okay, this one I come back later, part B. Find the cost function. Now C, linear function, is equal to mx plus b. So you need to find m, you need to find b. All right. So you are given what? You are given 2 points. So call it x1, c1. That is equal to fixed cost, which is 0, and 134,670. And then I give you the second point, which is equal to the production, or to produce 1,050 units. So it will cost us 2,800, 9,000. So those are the 2 points. So first you need to find M. Okay, so you find M. What is M? M is equal to delta C over delta X. from delta y over delta x, which is equal to what? Which is equal to C2 minus C1 divided by X2 minus X1. And that will be equal to, then only you put in the numbers, correct? That will be equal to 289,000 minus 134,670 divided by 1050 minus 0. You work it out, that will equal to 154330 divided by 1050 equal to 146.98. So that is M. Okay. So what you have now is 146.98 x equal to plus B. Now what you do, there are a few people, you don't find M. I don't know how you do it, but you find X. Okay, you got X equal to, I don't know, you find it average, the variable cost, and then you got X equal to 146.98. Now that is not X. X is the variable. What you find now is the slope. Okay, you cannot find the X. X is the variable. And so if you say X equal to 146.98, I don't know. Whether you misunderstood or you think that X is the slope, which is wrong. Okay, so you got M equal to that, and then you know the fixed cost is B. Okay, fixed cost is B. But you know, we just go by the theory, by the method. We find B. Okay, you find B by substituting any of the 1 point into C, and then you find B. And that you will get, of course, the value of the fixed cost. So to find B, all right, to find B, of course, you know it already, but I expect you to do this, you know, just show the method. Substitute 1 point, all right, say the first point, 0.134670 into C, all right? Then you got 134,670 equal to M, all right? 146.98 multiplied by 0 plus B. And then you will get B equal to, then B equal to the fixed cost, 134,670. So now you got B and you got M. So that would be our cost function. Okay. So you know, when I discuss this, you just go through your answers. Okay. You don't have to write everything that I wrote here. That will take a long time. You just go through your answers and see where you did the mistake. Now, some people, you oversimplify. Okay. You don't show the work. I told you, you know, it's better to show extra work. Whatever you do, okay, don't do it in another piece of paper. And then you write the answers on the paper that you submit to me. That is not right. Okay, whatever work you do it on the paper that you submit to me so that I can see how you get the answers. I don't want to see the answers. Okay, I want to see the process. Okay, if you just give me the answer M is equal to 146.98 without working, then how do you get it? I might suspect you copy. Okay, so it's better for you to show more work rather than less work. Okay, so the rough work that you do, just let me see it. I can give you extra points, you know, I can give you some points, even though your answer may be wrong, but I see how you work it out. Then I know that we understand something. All right, so that is the cost function. And you can write out the cost equal to 146.98x plus 134,670. So that first part A would be 5 points. Okay, 5 points. Now the second part, find the break-even output level. So what you need, of course, you need the revenue. Revenue is equal to P times X. That is equal to 96.5X. Okay, P is given as 96.5. So that is our revenue. Profit is equal to, therefore, the revenue minus cost. Okay, that will be equal to 96.5X minus the cost, which is 146.98X plus 134,670. And that is equal to, you have to subtract, break out the bracket, all right? So when you count the bracket, you got 96.5X minus 146.98X. That will be equal to negative 50.48X minus, okay, you have a plus sign over there, minus outside the bracket, so that becomes a minus. So minus 134,670 equal 0, okay, for break even. Right? So that will be equal to what? Then you can find X. So X will be equal to 134,670 divided by negative 50.48. All right? And that will be equal to negative 2667.79 units. Now, you have got a negative value. Since in real life, okay, in application, X should be bigger than 0 or at least 0. So therefore, to break even, how come you produce negative output? Okay, to break even, produce what output? How much output? Produce 0 output. Okay, so produce 0 output because there is no such thing as negative output. But you know, many of you just maintain the negative output. It's okay lah. You know, I didn't take out any point. So that part, 5 points. Now, one thing is, many people stop here. Now, when you do this application, I told you in the class, okay, when you got the answer, you don't stop there. You have to describe. Okay, you have to describe that answer, that value. What is it? It's the break even. Now, what does it mean? It means that for break even, you have to produce or you have to sell. Okay, whether you use produce or you sell, it doesn't matter lah. 0 output. So you need to, you know, you need to describe that point or the value. Don't just stop there. Okay, don't just stop there. You have to describe because it's application. Okay, application meaning you have to know. Okay, what the value is about. All right. Okay. Any question? So question number 1, 10 points. Okay, 5 and 5. Okay, good. All right. Now we move on to question number 2. Okay. Siap, eh? Dah finish? Finish? Okay. Now question number 2 is on the derivative. First question is you want to find the output level that maximize the profit. So we need to find the maximum point, okay, a maximum point for this function, which is profit. So we know that you need to find, okay, you need to find the x. So again here, What is profit? Profit is revenue minus cost. Okay, first, you need to find the revenue. Now, R is equal to P multiplied by X. So that will be equal to, okay, which is given as the demand function, 100 minus 9x multiplied by x. That will be equal to 100x minus 9x squared. Okay, given P equal to 100 minus 9x. So that is our revenue. Now for the cost function, I didn't give you average cost, I just give you cost. So it will fit in nicely. So therefore, our profit function is equal to 100 minus 9x squared, and minus the cost. So put in the cost function, don't break out the bracket yet, okay? Because we want to see its revenue minus cost. So x cubed minus 9x squared plus 46x plus 25. Now you can break out the bracket. So you got 900, 100x. Okay, I'm sorry, that should be x. 9x squared minus x cubed plus 9x squared minus 46x minus 25. So I do this because I want to show how you break out the bracket. Okay, when you break out the bracket, make sure the signs are correct. So negative and negative become positive. Okay, that will be equal to what? That will be equal to, you got 100x minus 46x. That will become 54x. 9x squared, 9x squared, negative positive, that becomes 0. So you got negative minus 3x cubed minus 25. Is that right? 100 minus 46, you got 54. 9 and 9 cancel out, you got negative x cubed, and then negative 25. So that is our profit function. Now, first, okay, we need to find what? Critical point. Okay, critical point, P prime equals 0. So P prime is equal to what? Is equal to 54 minus 3x squared. All right, set that to 0. So for critical point, P prime equal to 0. So I don't have to write that then, because I already put it at the beginning. For critical point, you got 54 minus 3x squared equal 0. Or you can put the P prime over there. So what you have? I have 3x squared equal 54. X equal to 54 over 3 x squared. I'm sorry. That will be equal to 18 point. That will be equal to 18. Is that right? 24, 1. Okay, will be 18. So x will be the square root of 18, and that will be equal to plus or minus 4.24. So square root, you know, there will be two values, plus or minus. Now, you say that since, okay, in application, x is positive or 0, so therefore, x is only equal to 4.24. If you don't do that, that's okay too. You know, you can just ask for the 2 points. But you don't have to, you know, because in application, we only worry about the positive output, 0 or positive. So you just take out the first value. All right, 4.24, because negative value is not relevant. or you can say negative X, not 11. Okay, all right. Now we do the test. Okay, so the second part is you want to test for maximum and minimum. So second part is you take the second derivative. P double prime is equal to what? P double prime is equal to negative 6x. And then you can test that at x equal to 4.24. What is P double prime? P double prime is equal to negative 6 multiplied by 4.24. And that will be equal to negative 25.46. And that is less than 0. So profit function has a maximum, or profit is maximum, has a maximum at x equal to 4.24. Or you can say profit is maximum at x equal to 4.24. You can find the profit, okay? Or you don't have to, because I asked the question in part C, okay? So that one will give you a part C. But if you do it here, that means you answer C that way, you know, you answer C right away. Maybe a few of you give me again, you know, in part C, the profit. Now, this question number part A, the first part, okay, because the first part is quite a lot of work. From getting the revenue, and then you get the profit, you do the critical point, that will be 7 points. Okay, so that's why I said, whatever you do, write it here. Okay, show everything, x equal to square root. You don't have to use another piece of paper. Okay, just show your work. Every work, show it here. You know, some people they express. You know, you got p prime, and then suddenly, boom, answer is x squared equal to 18. You know, I don't know how you got it. Okay, so show work. Okay, show work, because you show me more work, then I can see that you understand what you're doing. You know, if you show me less work, how can I give you points? You know, I'm not looking for answers. I'm looking for what? The process of how getting the answers. Of course, the answers are important also. So that first part is 7 points. This one is 4. The second derivative, 4. Now, this is important, right? There are a few of you who did not write negative. Okay, you don't do that. You just say from here, suddenly maximum. You know, what do you mean? So you have to write it nicely, you know, properly. Say that it's maximum. The function has a maximum value at x equal to 4.24. If the p double prime is negative, so you have to say negative means less than 0. Okay, and I have seen you just say p double prime equal to equal to 25.46, then maximum. So I don't know what you're talking about. Okay, so right, you know, the important things, right. So that is part A. Now for part B, I want to find the price. Okay, so to find the price, substitute P equal to 4.24. Oh yeah, I forgot. You have to describe that point. Okay, so we describe the point. So you say here, to maximize profit, okay, that is for part A. To maximize profit, you have to sell 4.24 tons of the good. What is no, wait, and of what? Huh?
Full oil.
Apa dia?
Full.
Oil. I'm oil. Of the oil. Apa oil pun tak tahu. Okay, so that is part A. Now for part B, you want to find the price. So to find the price, we substitute x equal to 4.24 into the price function, into P, where that price function is equal to 100 minus 9x. Okay, and that will be equal to 100 minus 9 multiplied by 4.24. That will be equal to, if you do the computation, then you will get 61.84. So we can say the selling price P, or the selling price is P equal to 68.84 RM. The selling price is, you don't have to say like that. The selling price is RM 61.84 per ton. Or you don't have to write that per ton, you know, because when you say price, always per unit. So you just say RM 61.84. So that is part B, 3 points. Okay. And then for part C, that is actually, if you do it there, then you answer C already. But many people, they find the P in part A here, and then C, you do it again. So that'll be okay. So part C, you find the profit. Okay, to find the maximum profit, then you substitute. Again, x equal to 4.24 into the P function. All right. What you get will be P equal to, if you substitute, you will get P equal to negative 4.24 to the power of 3 plus 54 multiplied by 4.24 minus 25. And you get the value. I think you get 127.73. So we say that the maximum profit is RM 127.73. So that is part C, 3 points. Now for part D, at X equal to Z10, interpret the marginal revenue. So you know the revenue is equal to, which we already have in part A, 100x minus 9x squared. And R prime is equal to 100 minus 18x. And at x equal to 10, marginal revenue, R prime, which is equal to what? Which is equal to dr, dx, equal to 100 minus 18 multiplied by 10. Multiplied by 10, you get what? You got 180. All right, 180, so it's negative. Now, when you interpret, it's again, you know, go back to the delta R over delta X. That means for a 1 unit increase in X. So I want to interpret that value. So the interpretation is at X equal to 10, because it's nonlinear function, if output increases okay, by 1 unit. Then the revenue will go down or decreases by 80 RM. Okay, now some people, you have output increases by 1 unit, but you say here marginal revenue. Okay, marginal revenue decreases. Now we are not talking about marginal revenue decreases. We are talking about what? We are talking about the marginal revenue. From there, when you interpret, it's not the marginal revenue that's changed. The one that changed is what? It's the revenue. Okay? Because marginal revenue is the change in revenue. If you're talking about the change in marginal revenue, then you have to differentiate the marginal revenue function. All right? So that's one mistake. Okay? You say, because I didn't say the marginal is going to change. I said the value, okay? The value of the function is going to change from the slope. Okay? So that is one mistake. The other mistake is if output increase by 10 units. Now output do not increase by 10 units. It's about what? It's about the point of the derivative, x equal to 10. Okay, output don't increase by 10, output increase by 1 unit because you get the R prime equal to certain value. So when you interpret, you have a small change in x, which is 1 unit. So x increases by 1 unit, then what happens to the revenue? So this is another mistake that people do. Output increases by 10 units. So those are the comments I have so far, okay? From the answers that I've graded, these are the common mistakes. And that would be 3 points. Okay, generally, many people do not describe, okay? You miss the description, you just leave it here. Just give me the answer. That's number one. Number two, of course, interpretation here is not right. And mostly, you know, from the previous part. That means you don't show the complete steps, all right? So that was the other one, especially the second derivative test, lah, correct? And even many people do not do the second derivative test. You just conclude from here, you know, that. Now you don't have to do the second derivative test. You can do the first derivative test. That is also good, okay? But like I said like I said earlier, if you use the second derivative test, you save a lot of time. If you do the first derivative test, you know, you have to find the interval, you have to test the point for each interval, so that will take a lot of time. If you do the second derivative test, you can do it very fast. Okay, any question? So you evaluate your answers, you know, compared to the solution. You can see, you know, where your mistake was, and then improve from that. Okay, hopefully you don't repeat the same mistake again in the future. Okay, anything that you want to raise?
Sir, can we back to question 1A?
Okay, question 1B.
A.
A. Okay.
Okay. Since in the question they have given the total cost, which is 298,000. Then if I find the slope just by inserting the total cost, and
you
then
can find the slope like that. Okay, I need to show how you get the slope. Like I said here, you know, when you do that way, either you use the variable cost. Maybe I haven't checked your answers, you know, but from the from the papers that I grade already, you don't use M. People use X. Okay, when you do that way, you know, you do what you said, then you got X equal to 146.98. That is not X, that is the M. Now you don't have to use like what I do here. You know, maybe you have another method like what you said. But as long as the method makes sense, you get M, that'll be okay. All right? So if you use the other method, I saw people using it, but you use it wrongly. Why don't you use this one? Okay, this one is what we learned in the class. Okay, you have 2 points. You find the slope by taking the difference between the two values. Then you get the slope. So again, some people that I did the correction, you got X equal to that thing. So that is wrong. I know maybe you mean it's slope, but you put X. Okay, all right. Okay, anything else? Okay, good. So we get ready for midterm, okay? Now is the second week of the second half. So probably we're going to have a midterm in 2 weeks' time. Okay, 2 weeks' time. Because after that, you have the final. So I need to have the midterm by at least the 3rd or the 4th week. So 2 weeks. Okay, in 2 weeks, you have the midterm. That will be whatever the coverage is, you know, when whatever we can cover at that point of time. So there is no time to rest, okay? There is no time to rest. And I see here, you know, about 20 people missing. So on average, you know, I cannot check your attendance because there are too many people. It takes me time, you know, just to check your attendance. So I'm not going to do that. I know, you know, on average, every day, about 20 people missing. 20 people, that's a lot, that's a high number. So for those people, like I said earlier, maybe I didn't say it here, I say it to another class. If, you know, your friend or whoever they are like to be absent now, you know, second half of the semester, better withdraw, you know. I don't want to have more people fail, you know, it's not good. But if you think that you are not really into this, withdraw, you know, withdraw, take again next time. Because if you like to be absent, then there is no point. All right, you are wasting your time. Because after that, you have to hear the recording. You know, you listen to the recording without really attending, that's also a problem. So you're wasting time. If you attend the class, you make your time efficiently, okay? Because the recording is optional. The recording is not the primary tool, you know? The primary tool is attending the class. So if your friends, you know, like to be absent, then tell him or her. My advice is drop the course, all right? Okay. I prefer these people, 100 entity, you know, every day, same people who come, and those who 20 people who don't come, better leave the group. Okay, just like WhatsApp group, leave the group. That is for your own good, not for my good. So that is my advice. The second half, if you still have that attitude, like to be absent, I think you have to evaluate yourself. Or if you're not willing to work hard enough, okay, then better withdraw, you know, think about it. I don't want to have more people failing the course. I want more people to pass, okay? All right. Okay, anything else? So what I plan to do today, I will do the second derivative test for maximum or minimum for the partial derivative. Now, when we finished our class last week, we left with the determination of the critical point. So that's where we left. Because critical point, okay, if you look at this diagram, can be a maximum, can be a minimum. So that critical point is the first part of the test. You need to find the critical point, and we found the critical points. The condition for critical point was what? The fx equal to 0, fy equal to 0. So from that partial derivative, you have two equations. And from these two equations, we have a system, okay? A system of equation may not be linear, all right? One function can be linear, the other may not be, or both are linear, okay? And you find the solution, you get the critical point. Now, sometimes you may have more than one critical point. So if you have more than one critical point, then you need to find all, okay? All critical points, because sometimes you can have two, okay? Or sometimes you have three. But for our case, okay, mostly for our course, mostly you got to be two or one, all right? So normally you don't have three, you know, because the function will be too big. We have, if the function is, there is a cubic function, then you may have two critical points. So you have to find all, okay? So if there are 2 points, then you have 2 critical points, and then you do the test. So this is where we left last class. And then I give you some examples, okay? I hope you have done that one. So here you got the critical point, one critical point, and then I think I give you another question. And in fact, I give you a few questions. So any question about, or any problem with the questions to find the critical point? Okay. Okay. All right. So given everything is okay, we will do the second derivative test. So in 2 weeks, maybe you have another, no, another lah. You have the midterm. And then after that, you know, I give you another homework. So the test. After you have found the critical points, we take the second partial derivatives. To take the second partials, okay, namely fxx, fyy, fxy. And if you want, you take also fyx. But we just need this one. After that, we have to make use of the d. Well, you know, we call it d. So d is defined as follows. D, okay, is equal to, oh, that is the second derivative condition. So D equal to, sekejap ya, saya tengok. Because that D is slightly different than the one that we were doing the first derivative then. Sekejap saya cari D dulu. Mana dia terletak? Yang ada. Okay, you find the D, define D equal to fxx. I think I will write the full form. So you find D, and D is a function of x and y that is equal to fxx, which is a function of x and y, multiplied by fyy, and that is also a function of x and y. You have to take away, subtract fxy, and that is a function of x and y, everything here squared. Now these are functions. The second derivatives are all functions. Fxx is a function of x and y. Fyy is also a function of x and y. and fxy is also a function of x and y. So therefore, d is a function of x and y. Now, you don't have to write that thing all the time because it is quite long. In short, we just write d is equal to fxx, fyy, minus fxy squared. So here, that is the shorter version. You don't have to write in functional form. And we know, okay? We say when we do that, we know that these are all functions. Okay? So we know that they're all functions. You don't have to write it in the longer form. Just write it here. And in this form, it's easier to remember. You know, what is d? D is fxx multiplied by fyy minus fxy squared. So here, easier to remember. Then we have to evaluate. Okay, you have to find the value. You have to evaluate d at the critical points. Critical point or points. So how do we do that? Again, we just substitute. Okay, you substitute the critical point into d. All right. So for the first part, we already have the critical point. So let's say the critical point, you call it x0, y0. So the first part, okay, the first part that we were doing last class, you have the critical point where the fx equal to 0, fy equal to 0, that's the critical point. Now suppose that point is x0, y0. You know, maybe you get 1 and 2. So we substitute that value into the d, okay? So now you have at x0, y0, then you have a specific value of the d. So that d, I write now in full again, okay? x0, y0 equal to, because we need to see how we substitute x0, y0 multiplied by fyy x0, y0 minus fxy, substitute the value x0, y0 squared. So that's how you got the d, okay? You substitute the x0 into the function d, okay? In other words, you evaluate d at x0, y0. Now, when you do that, or you just write in short form, okay, evaluate d, then you get the value of d. So at x0, y0, you get a d. So at x0, y0, you got some value of d, correct? Call it d0, because x0, y0. Now you got the value here, and that value is a number, okay? Now when value is a number, how do you categorize a number? Normally you have a number d, you know, can be that will depend on the value of the second derivative, and of course also the value of the critical point, okay? Now when you have a value, how do you categorize the values of a number? Because it can take you, you know, possibilities, so many numbers, infinitely many possible values. Now, how do we categorize this value? Say, you know, the d0 can be equal to 4.25, or d can be some other number. So how do you categorize a number? Okay, we categorize this as the following. Number one, A. Okay, call it number one. If, okay, d0, the value that you got at d at x0, y0 is bigger than 0, all right? And then you may have number 2. What is a possibility? D0 less than 0. What is number 3? D0 equal to 0. Okay, so you have 3 possibilities: bigger than 0, positive; less than 0, negative; 0. Okay, so now if the value of D that you evaluate at the critical point, call it D0, is bigger than 0, then we may have, or the function may have a maximum or minimum. So let's just focus on the first option. So if you do that, if the D is bigger or equal to 0, then possibility, okay, possibility here is if D is bigger than 0, and, right, A, if fxx, fyy are both, okay, less than 0, then the function fxy, okay, equal to z has what? A maximum at x0, y0. B, if the value of the second derivative at x0, y0 are both bigger than 0, then the function has what? Has a minimum at x0, y0. Okay, so first part is the most important. That means 3 things here you need to check. Number 1, the value of the D that where you evaluate at x0, y0, the value, if it is positive, then you may have a maximum or minimum point. All right, but you need to look at some other things as well. The second condition is like what we state in A and B. If fxx at x0, y0, fyy at the point x0, y0, both, okay, less than 0, negative, then you have a maximum. Or in other words, the function has a maximum at that point. If fxx, fyy at the critical point x0, y0 positive, then the function has a minimum at the critical point. So 3 things here. Okay, number 1, D bigger than 0. Number 2, fxx, fyy. Right? Whether they are positive or negative. Then only we can conclude whether the function has a maximum or minimum at the critical point. Now, for condition number 2, if the D at x0, y0 is negative, then the function has a saddle point. So don't worry about the saddle point, okay? We are not interested in saddle point. So if you got saddle point, you stop there, all right? And if it is equal to 0, the test doesn't work. Because the test has limitation also, So if it is equal to 0, that means you have to have a further test. This is quite critical, So you have to have further tests in order to test whether, you have a maximum or minimum. But the test doesn't work. And normally you don't have a maximum or minimum. So don't worry about the thing. So for 2 and 3, if it is negative or 0, then you just conclude accordingly, and then we stop there. All right. Now, the one that we are interested in, should be the first part. if D is bigger than 0, and then you have what? You have the possibility of a maximum or minimum point, depending on whether the second derivative, fxx, fyy, are positive or negative. So that is the second derivative test for a maximum or minimum. Okay, any question, any comment? Okay, good. Now, so make yourself clear, okay? Now, I would like you to go back to the example that we were doing earlier. I think, what was the first example that we were doing? Okay, Yani. Okay, yeah, one more thing. Now, if you have more than one critical point, all right, if I have more than one critical point, then you have to repeat. Okay, you have to repeat the test for each critical point. All right, that means you have two. Let's say you have two. Okay, if there are two, then you have to do it, the test. You have to do the test twice. Okay, you have to do the test 2 times for each of the point. So you have to do the test for each of the point. So if there are 2, then you have to do the test 2 times. Okay, so let's go back to our example. The example that we were looking at was the function here. Okay, you go back to this function. This is the simplest function, where you have the first derivative, okay, critical point, fx, fy, that will be equal to 1, 0. And of course, you find the value of z. Okay, now for this example 1, apa function? You remember the function? What's the function I give you in the book, ataupun I give you another function? What do you function?
100x.
Huh?
1/4.
Function tu saya bagi ke ataupun dalam buku?
Sebagi.
Okay. Now, tell me the function. Because I bagi tapi saya tak tulis pula dah. Mana pergi? Tak ada. Dalam ni pun tak ada. Tak ada. Oh, tak ada. Oh, okay, you give me the function again. What was the function? Z equal to apa ni?
X square
X squared
plus Y square
plus Y squared
minus 2X
minus 2X
plus 1.
plus
1.
1. Okay, so that was the function. Now, we already did the first part. Okay, find the critical point. You have the 2 partial derivative, fx, fy. We have the value, critical point, x equal to 1, y equal to 2. Of course, you can find the value of z, or you don't have to find now. Okay, you can find later. So what I want you to do, based on this one, you do the test. Okay, so you compute the d. That means you have to find the second derivative, fxx, fyy, fxy. Okay, apa dia?
This question is the function is not that.
Oh, lain. Apa function dia?
Another function.
Okay, give me the function. Betul juga betul lah ni. Kalau fx, I take 2x minus 2. Okay, fy or fy 2y. Okay, what is the function? Saya rasa x squared dengan y squared betul dah. Apa function dia?
Sorry, sir. Correct. Yeah.
Yang ni betul tak?
Ya, betul.
Okay. So you get the second partial derivative. Okay, go by that D. I want you to try first, okay? And then I will do it together. So you get the D, all right, based on the second partials. And then you evaluate that D at the critical point, which we already have. Yeah. So finish up this example, and then we will go through together. Okay? Okay, do it now. I'll give you a few minutes to finish it up. Okay, you got it? Now, what is fxx? So for that example, okay, we finish it up here. For that example, where the function was equal to, that first example, you already have the critical point. So number one, you have already the critical point. Okay, critical point, we're done. So you have the point dia tadi berapa? X equal to berapa? Point? Saya dah lupa. Critical point berapa ni? 1, 2,
1.
X equal to 1, Y equal to 0. Okay, so critical point, you have X equal to 1, Y equal to 0. And of course, you can find the value of Z now, or you can do it later. So critical point, call it X0, Y0 equal to 1, no, 0 to 0. 2 ke 1 ni? 1 ke 2?
1.
1, 0. So that is the point. So we've got the point 1, 0. Now you need to find D, okay? And we know you do the first part, that is already being done. Now for part 2, you need to find the second derivative test. So we know that D is equal to fxx, fyy minus fxy squared. So you need the second partials. So number one, you got to find fxx that is equal to 2, fyy equal to 2. What is fxy?
0.
0. Okay, so you got 0. Now everything here is a constant. So it's very straightforward. So therefore, d is equal to 2 times 2 minus 0. That is equal to 4. Okay? So now what you do, even though it's a constant, but we go to the step, all right? So our method say you want to find the value of d at the critical point. So at 1, 0, what is d? D is still is a constant, so everything is the same. So d is equal to 4, so it's a constant. All right? Which is what? Which is bigger than 0. Since fxx, fyy are all fxy are all what? Are all constants. So that is bigger than 0. So now, if it is bigger than 0, do we have a maximum or minimum? We do, okay? That is the first condition, P positive. And then you have to look at whether fxx, fyy are both positive or negative. So if d is positive, so now you have d equal to 4 is already positive. Then you have to look at fxx. And, okay, that is the second set of the condition. fxx is equal to what? Is equal to 2. And that is positive. fyy is also equal to 2. That is positive. So now, if I just go through the conditions again, you have the first condition, okay, bigger than 0, that is satisfied. Now you have the second condition, which is also satisfied. So, what can you say about the function?
Minimum.
It has a minimum. Okay, because both are positive, so has a minimum at the point 1, 0. Okay, and of course, you can find the value of that. After that, you find the value of the function at the point. So you get the value of the function at 1, 0. So if you do that, then you have the point as 1, 0, the value of the function. So the full point will be 1, 0, whatever the value that you get there. Okay? So what does it mean? It means that the function has a minimum value at 1, 0, and the minimum value is the value of the z, okay, or the value of the function at 1, 0, which is equal to whatever the value that you get. Okay, so that is our first example. Okay, any question? Okay, now, second example. We're going to finish up the second example. I gave you last time 2 examples. So if you look at the second example that I gave you, example there. Did I give you another example? Oh, tak ada. Tak ada. So tak apa. Itu je lah. Alright. Now, let's go to the homework question. I gave you a homework question last time. What was the question? So we do one of the questions. That's our second example. We'll go to 14.4. 14.2, 14.3. 14.3. Application 14.4. Okay, 14.3 ya. Itu saya bagi soalan 14.3. 14. Did I give you a question on 14.4? 14.4. 14. 2x. I give you another question. I give you just a fresh question. Okay, I think this question is a good one. All right, I would like you to go to section 14.4. 14.4, I want you to do question number 9. Okay, we have 10 more minutes. So do that question number 9. So number 9, function dia macam ni tu. X squared yang plus 6xy tu. Plus. So if you have another addition, so maybe different number. So do that question, all right? Okay, do it now. You find the critical points, and then do the second partial derivative test. So itu I give you 14.3. 14.3 dah bagi dah. 14.3 bagi mana? 14.2 pun bagi dah kan. So 14.2, 14.3 okay. So today kalau I bagi pun I want to give you some questions on 14.4. 14.4 I will give you questions. Alright. Now 14.4 homework question. Number 9. So do some other questions. So do number 2. Okay. Number 2 and then number 6. Number 9 we're doing now. And then do number 15. Waduh, 3 question lah. Okay, you have the critical point. What is fx? What is fy? Cepat. Siapa yang dapat tu? So number one, critical point. Berapa dapat ni? Fx berapa dapat?
2x plus 6y plus 16.
Plus
16.
16. Everybody got that? Okay. Now, fy. Everybody dapat apa?
6x
6x plus 2y.
Plus y.
2y.
2y. Plus?
That's all.
That's all.
That's all.
Okay. Now, for benda ni right? Is this correct? Okay. Now, for critical point. Okay. For critical point, that means you set both equal to 0. fxx equal to 0. Fy equal to 0. So you have two equations here. 2x plus 6y plus 16 equal to 0. So you call it number 1. And then number 2, you got 6x plus 2y equal 0. So that is our number 2. So you solve the system here. There are linear functions, okay? So you solve the system, you work it out, then you will get the value of x and y. So that will be our critical point. Okay, if you work this out, what do you get? X and y. So, nah, buat ni. Okay, X berapa dapat? Anybody? Siapa yang dah dapat lah. Siapa yang tak dapat tu buat lagi ya. X berapa?
1.
X equal to 1. What about Y?
8.
Negative
Negative 3.
Negative?
3.
3.
Negative 8.
Negative 3.
Saya budak minta.
Y negative apa?
Budak bagi nombor account.
Negative 8 ke negative 10?
Negative 3.
Negative 30? Ya betul, negative 30.
Negative 3, sir.
Negative 3.
Negative 3. Biar cakap betul. Okay, negative 3. X equal to 1, Y equal to negative 3. So that's our critical point. Of course, you can find the value of Z. Kat situ eh? Alright. Now, that's the first part. The second part, you do the second derivative test. You know that D is equal to what? So you write this a few times, you know. You write this a few times, you remember it. Okay? You just write a few times. Practice. D ini equal to that. So you need to find fxx. Okay? Which is equal to what? fxx equal to 2. Okay, based on the first partial. Fyy equal to 2 also. Betul tak? fxx, derivative of fx with respect to x, you got 2. Fy is also 2. And then we need fxy. Fxy, differentiate fx with respect to y, I got 6. To check, okay? To check whether it's right or not, you find fyx also equal to 6. So that's correct. Okay, so to check, you just make sure it's equal to fyx. So you got the partials or the second partials that needed for the D, and then we substitute into that D. So D is equal to what? D is equal to 2 times 2 minus 6 squared. So D is equal to 2 multiplied by 2 minus 6 squared. All right? And that is equal to 4 minus 36. So that is negative 32. Now you know it's already negative. All right? Just do the test. So at x equal to 1. X equal to 1. Y equal to negative 3. D, since it's constant, is equal to negative 32 less than 0. Now less than 0, you will see, you know, it's not whether whether the function has a maximum or minimum, because the first condition is D positive. So when D is less than 0, Z has a saddle point. So don't worry about the saddle point. We just stop there. So that's it. Okay. That means saddle point. Saddle point is not a maximum or it's not a minimum. What you're interested in is, of course, getting a maximum or minimum. Okay. All right. Good. Any question? Anything? So I give you already questions on 14.4 today. Okay. So do those questions. Make sure we are already be able to do the test. And then next class I will do the application. Okay, we're going to look at the application. And then we are going to finish up the chapter. So hopefully by next class I can do the application. And then we finish up the chapter. We do the 14.5. Okay, all right, good. Okay, any question, anything before we go? Okay, good. All right. So I will see you again Wednesday. Have a nice session. Okay, practice the questions. I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
All right.
Sir, thank you, sir. Have a nice
All
day.
right.
Sir, thank you, sir.
Thank you.
Thank you, sir.
Thank you,
Thank
sir.
you, sir. Have a nice day.
Yeah. Today I have a friend,
Thank you,
good
sir.
friend, just passed away last night. So this morning we heard the news. It's quite sudden. He was healthy. And last night I heard that he passed away. So as you grow older, that's life. Time for us to pass on. Okay, I'll see you again.
Thank you, sir.
All right, thank you.